function 3, we're still looking at analyzing functions. We're going to get into learning target 2, which, by the way, is in 4 parts, part A, B, C, and D. So all of them, your goal is to write linear equations. So we'll talk about that. And this first one, we're going to do it just from this first part here from a 2 xy values. And then the other parts, we'll do it from a table, a graph, or a context. So we can describe slope as the following: rise over run. So rise is how high something goes up on the y-axis between 2 points, and a run is your horizontal change. So we have our vertical change over our horizontal change, or sometimes you'll hear it as change of the y over the change of the x, and all of these are the same idea here. And because you can also name it from those 2 points, and so what we're going to work on. So we're going to use the equation y2 minus y1 over x2 minus x1. And this is the slope formula that we'll be using in part A. So I want you to pause the video, and you need to write down those 4 steps of how to solve, or I should say, write a linear equation in slope-intercept form, which is y equals mx plus b, from these 2 points. So go ahead and do step 1, 2, 3, and 4. So we're going to take those 4 steps that you just wrote down, and we are going to do the same thing over and over on the next couple examples to show you how. So step 1, and I wrote it nicely here for you. We're going to calculate the slope, and we're going to calculate it using y2, I'll write that equation, minus y1 over x2 minus x1. So you're going to take this first points, or I should say you're going to take these points 3, 4, and 5, 8. And you are going to designate which one is going to be your first set and your second set. And mathematically, it doesn't matter. Of course, this is your x, and this is your y, and this is your x, and this is your y. But it doesn't matter if you call this x1, y1, and this one x2, y2, or if you want this one to be 1 and 2. You just have to make sure that x1 and y1 are in the same pair, and x2 and y2. So now that we know which one is which, we're just going to put them over these equation, or put it into this equation. So this would be 8. Your y1 is 4. Your x2 is 5. And your x1 is 3. And you're going to go ahead and do your math. So 8 minus 4 is 4, and 5 minus 3 is 2. So 4 divided by 2 is 2. So your slope is 2. Or you can write it, if you like it, in the ratio form of rise over run, or the change of the y over the change of the x, 2 over 1. Second step, as you wrote on the other previous page, solve for the y-intercept by picking and plugging in one of the 2 points, and then you are going to solve for b. So you're going to come up here, and it doesn't matter. Don't overanalyze this. We'll just use this first time. So I pick the point 3, 4, and then I'm going to plug in the slope from step 1, the y and x axes that I just picked, values I should say, that I just picked. So I have 3, 4, this is my x, my y. So I'm going to take the equation y equals mx plus b, which we've practiced in the last functions. And so instead of, we're going to actually plug in that value of y. So as I said, the slope, y, and x values. So the y value is 4. The slope we found in step 1 is 2. The x value of the point I picked is 3. And notice you're going to solve for b. Because remember, our goal is to put it into slope-intercept form, or make that linear equation of y equals mx plus b. So just solve a simple equation here. 2 times 3 is 6. And I want b alone, which means I'm going to subtract 6 from both sides. So 4 minus 6 is -2. So b equals -2. Step number 3, you're going to write the equation with only the slope from step 1, the y-intercept from step 2, and then the x and y variables. So in other words, you're going to put it into slope-intercept form. So y equals m, which is your slope, which from step 1 was 2, always an x, and then minus, or you can put plus a negative 2. And the last part is to check to make sure our equation is right. So we're going to check with the 2 points that we started with, because we know these 2 points are on the line. So if I plug this into the equation, it should be mathematically true, because these points should be on this line. So xy, so 4 equals 2 times 3 minus 2. So 4 equals, you can either punch in your calculator, just do it in your head. 2 times 3 is 6 minus 2, and 4 does equal 4. So I know that the point 3,4 is on that line. We're going to work with the other line. Okay, so y equals mx plus b. So y, which is 8, equals our slope, which is 2. The x that we said is 5, and we're subtracting 2. So again, you can plug in a calculator, check it, or do it in your head. 5 times 2 is 10. Then I'm going to subtract 2, and that equals 8. So I promise you that this is the equation that would have the points 3, 4, and 5, 8 in it. So the question is, what is the equation of the linear line that passes through the points 4, 5, and 8, 4? So again, our goal is to get this into y equals mx plus b form. So step 1, calculate the slope. So remember, slope equals y2 minus y1 over x2 minus x1. So we're going to take our points, 4, 5, and 8, 3. Actually, I'm going to put that up here. So I like to write underneath them. Okay, and again, it doesn't matter what points you pick as your set 1, but that one's your x. We'll make the set 1 here. I usually make the first one. And then the second set, so x1, y1 in the first set, x2, y2. You make sure that you are able to label those correctly so then you can plug them into the equation correctly. So y2, which is 3, minus y1, which is 5. And we're going to put that over x2, which is 8, and then x1, which is 4. So 3 minus 5 is negative 2, and 8 minus 4 is 4. And if I reduce that, my slope here is 1/2. So step 1 done. Step 2, solve for the y-intercept by picking one of the 2 points from the question and plug in the slope, the x and y values from your points, and then into the equation y equals mx plus b. So I'm just going to pick the first one again. Again, that's your x, your y. So you're going to start with the equation format we're working towards, and then we just plug in what we know. So y is 5. Your slope was negative 1/2. Your x is 4 plus b. So why we plug in actual numbers for x and y is because we only want one unknown, and our unknown right now is the y-intercept. So we're just going to pick one of those 2 points and then solve for the y-intercept. So negative 1/2 times 4 is negative 2. Add b. I want to get rid of negative 2, so I'm going to add 2. So 7 is equivalent to b. So the y-intercept is 7, or we could write it as 0, 7. So here's my slope. Here's my y-intercept. Now we can make our equation. So y equals m, slope, which was negative 1/2, x plus the y-intercept is 7. And the last step is to check. So we're going to take those 2 points that we started with and make sure it truly checks. And then we had 8, 3. Okay, and then I'll get rid of that so it's not in the way. Okay, and then what we're going to do is we're going to plug them in and see if it works in the equation we just made. So we're going to take y equals, so y in this case is 5, equals negative 1/2 times 4 plus 7. So go ahead and put in your calculator or do it really quick in your head. Negative 1/2 times 4 is negative 2 plus 7 Negative 2 plus 7 is 5. So yes, this point is on the line that we said was y equals negative 1/2 x plus 7. Second one, same thing. This time your y is 3 equals negative 1/2 times your x, which is 8. Add the 7. So we get negative 1/2 times 8, which is negative 4, plus 7, which is really 3. So I can guarantee you that this is the correct equation because both these points fit on the line. And our last one. This time we're going to do 1, 2, and 5, 10. So 1, 2, call that x1 and x2 again. And 5, 10, we'll call that x2 and y2. So write down the equation. You'll get very used to this equation. As many times you'll hear me say it, and as many times as you'll end up using it. So y2 is 10 minus y1, which is 2, over x2, which is 5, and x1, which is 1. So 10 minus 2 is 8. 5 minus 1 is 4. So my slope again is 2 on this one. Pick a point. Oh, we'll just pick 5, 10 to be different, the second one. So x and y. So we're actually going to put these points in to the equation so that we can solve for the unknown y-intercept. So y equals, so 10, since that's my y value, the slope was 2, my x value is 5, plus b. So 5 times 2 is 10, add b. I want to get rid of a positive 10, so I'm going to subtract 10 from both sides, and 10 minus 10 is 0. So this time the y-intercept is at 0, 0, starting at the origin. So my equation, so it'd be y equals m, which is 2, x, and then you could put plus 0 if you want to, but we know mathematically that doesn't do anything. So we'll check our 2 points. We'll start with 1, 2. Remember, 2 is your y. We're just checking here to make sure this point is really on the line. So 2 times 1 plus 0, if you put that plus 0 there, is 2. So 2 does equal 2. And on this one, y is 10. So 10 equals 2, since that's my slope, times your lovely x, which is 5. You can put plus 0 if you want. 2 times 5 is 10. And so you end up with 10 does equal 10. So I can guarantee you that both those points are on the line y equals 2x plus 0.